Hey there, tech enthusiasts! Linus here, diving into microprocessors and microcontrollers. These tiny components are the unsung heroes of our digital lives. They're the brains behind our smartphones, cars, and smart toasters. Understanding them is key for any tech enthusiast. Think of them as the CPUs of the embedded world. They're calling the shots and making sure everything runs smoothly. We'll break down their strengths and weaknesses. So grab your thinking caps and let's get started. First up, let's talk about microprocessors. These are the heavy lifters of the computing world. They're designed for general-purpose computing, meaning they can handle a wide range of tasks, from running complex software to crunching massive amounts of data. A microprocessor is basically a CPU on a single chip. It includes the arithmetic logic unit, ALU, which does the math, the control unit, which directs traffic, and registers, which are like tiny memory slots. But here's the thing. On their own, microprocessors are pretty helpless. They need help from other components, like RAM, storage, and peripherals, to do anything useful. Think of it like this. A microprocessor is like a powerful engine, but it needs a car built around it to actually go anywhere. So where do we find these multi-talented workhorses? Everywhere. They're the brains behind our laptops, desktops, and servers. They power our gaming consoles and workstations. Basically, if it needs to do some serious computing, chances are it's got a microprocessor at its heart. Now, let's meet the microcontrollers. These little guys are like the microprocessor's more compact and specialized cousins. They're designed for embedded systems, which are dedicated to specific tasks. The cool thing about microcontrollers is that they pack everything onto a single chip: the CPU, RAM, ROM, and even peripherals like timers, analog to digital converters, and communication interfaces. It's like having a whole computer shrunk down to the size of your fingernail. This makes them perfect for applications where space and power consumption are limited. Think about it. You wouldn't want a bulky desktop computer controlling your microwave, right? Microcontrollers excel in these situations. They're the brains behind everything from washing machines and microwaves to cars and airplanes. They're also becoming increasingly popular in the world of IoT, powering smart home devices, wearables, and even industrial automation systems. Section 4. Microprocessor versus microcontroller. A head-to-head. How do they stack up? Let's break it down. Microprocessors are general purpose, like Swiss Army knives. Microcontrollers are application-specific, like a chef's knife. Microprocessors need external components, like RAM. Microcontrollers have it all on one chip. Microprocessors handle complex tasks. Microcontrollers are efficient for specific tasks. No clear winner, just different tools for different jobs. Section 5. Picking the right brain. Choosing between a microprocessor and a microcontroller. Now comes the million-dollar question. How do you choose the right brain for your project? Here's a simple breakdown. Choose a microprocessor if you need high processing power and speed. Your application involves complex calculations or large data sets. You need a flexible platform that can run a variety of software. Cost and power consumption are not major concerns. Choose a microcontroller if your project is an embedded system with a specific task. Space and power consumption are limited. You need real-time control and responsiveness. Cost-effectiveness is a priority. Remember, it's all about choosing the right tool for the job. Don't overcomplicate things. Section 6. Real-world examples. Microprocessors and microcontrollers in action. Still not sure which one to pick? Let's look at some real-world examples. Microprocessors in action. Gaming PC. That beastly gaming rig you built? It's powered by a multi-core microprocessor. Smartphone. Your trusty smartphone relies on a powerful microprocessor. Server. Those websites you visit are hosted on powerful servers with multiple microprocessors. Microcontrollers in action smartwatch. That fitness tracker on your wrist? It's powered by a microcontroller. Microwave. That trusty appliance uses a microcontroller. Car Engine Control Unit, ECU. Modern cars rely on microcontrollers. Both microprocessors and microcontrollers play crucial roles in our digital world. It's all about understanding their strengths and choosing the right tool for the job. Section 7. The future of tiny brains. The world of microprocessors and microcontrollers is constantly evolving. We're seeing faster processors, more integrated microcontrollers, and a blurring of the lines between the two. New architectures, like RISC-V, are shaking things up, while advancements in AI are bringing intelligence to the edge. The future holds exciting possibilities for these tiny brains, and I can't wait to see what amazing things we'll accomplish with them. So there you have it, folks. A crash course on the world of microprocessors and microcontrollers. Hopefully, you've gained a better understanding of these essential components and how they shape our digital lives. Until next time, keep on teching.